Thank you, Chris. Hi, everyone. I want to introduce Complimate, Navigate Fight and Case Submissions with Confidence, which is my project. I try to use what I learned in the boot camp and try to apply it to some efficiency improvements in my day job. So, what is a 510K? So, a 510K is basically a pre-market submission pathway for Class 2 medical devices. It's used by medical device companies to launch a new product and to demonstrate the safety and effectiveness of that product. So when FDA approves the submission, the device is cleared for launch. Even though it's called a device, this can actually be software, like a deep learning model that does arrhythmia classification. And that's when it's called software as a medical device. And so what goes in a 510K regulatory submission? The TLDR answer is a lot of documents and evidence, as you can see. And typically, all these documents and evidence, it's compiled by an internal regulatory team who has to work with a lot of cross-functional teams to kind of compile those documentation. So there's always room for error. So regarding medical device manufacturers, the companies, I just wanted to give some examples. You might have heard of these companies: Abbott Labs, Dexcom, iRhythm, Medtronic, Johnson & Johnson, and so on. So my problem statement is that the process of preparing and submitting a 510K is a significant bottleneck for medical device companies. The preparation time is anywhere from 6 to 24 months today, and then it takes about 6 to 9 months for FDA to approve the submissions with a lot of follow-up questions. And the inherent complexity of medical device regulations and evolving guidance with respect to the usage of AI and ML in medical device software leads to protracted timelines and increased cost and delayed innovation. So how can AI help? So my proposal is to build FDA regulatory assistant that'll help shorten 510K preparation cycles by 30 to 50%. And to give cross-functional teams a single pane that'll flag gaps and rank risks and link every finding to authoritative FDA-like guidance. And also to make the regulatory knowledge accessible to all the cross-functional teams with a Q&A chatbot style interface. So for my project, I used highly vetted training data like the Code of Federal Regulations, FDA databases, and FDA cybersecurity guidance, and the IMDRF guidance documents. This is what my architecture looks like. I have a user interface layer with Chainlit. It supports real-time streaming and file uploads. I'm using a LangGraph multi-agent orchestration architecture, which allowed me to have some kind of a modular design. Coming from a software engineering background, I tend to think modular, whether it's right or wrong. I'm still learning in the world of AI, but basically it allows for modular design and also allows for extensibility. Tomorrow, if I want to add a regulatory expert for EU regulations or Japanese medical device regulations, I can just plug that in. And if I want to delete something, I can delete it. So it makes it very extensible. So I have a tool suite and I have rack chains which are production ready. I'm using cache-packed embeddings and a quadrant vector store, and a knowledge base which is trained on cybersecurity and regulatory requirements. And I also have evaluation and observability where I'm using Raga evals and Langsmith tracing and synthetic data generation using Ragas. This is basically what my deployment looks like. The only thing I would like to add here is I'm using some pre-commit Git hooks where I evaluate the commits based on Raga metric thresholds and prevent PR merges if they are lower than a certain threshold. I'm also getting my files from an S3 bucket, and I'm using an ensemble retriever. So with that, let me switch to my demo. So I have a question here which comes from my Raga's ground truth database. As you can see, there's a chainlet interface. I have a regulatory assistant, and it's got a team of experts who can answer the question. So when I type the question, basically the supervisor LLM does some routing to the correct agent who will basically answer the question. So as you can see, the tokens are streamed, and basically it gives a very FDA auditor-like response, very comprehensive. And then it also, provides recommendations and source citations, which is pretty important, for compliance and regulatory tools. So the other feature I wanted to demonstrate is I have here a submission package, which has got a few errors, and I'll ask it do a compliance gap analysis. So basically, it's a zip file with a lot of regulatory documents and evidence that were synthetically generated. And as you can see, the supervisor agent routes it to the different domain experts who will perform their analysis, and they will use Scratchpad to share notes. And the zip file is unzipped, the documents are chunked, PDFs, documents, and text files are supported, they're parsed. The cybersecurity agent does its findings and recommendations and scores. Then the FDA regulatory agent does its analysis. And then there's a gap, compliance gap auditor who will perform an analysis and finally hand it off to a report generator, which will generate a comprehensive gap analysis report with an executive summary and an overall assessment and a recommendation, whether to go or not to go. The last thing I wanted to show is, a question, which is out of context. So what does the offensive line for the 49ers look like in 2025? A question that every Bay Area football fan wants answered. And as you can see, it says, this pertains to sports and team roster information. And I'm a FD auditor. I can't answer this question. So this is not ChatGPT. I just want to show that. And with evals, I'm using Raga evals. And, because I use an ensemble retriever, I was able to get some improvement in context recall, faithfulness, answer relevancy, and even context entity recall. I need to, use fine-tuned embedding models so that I can bump up the numbers on the context entity recall. That's what I found. Also using Langsmith evals, which got pretty good numbers with contextual accuracy, correctness, and chain of thought accuracy, as you can see. With regards to next steps, I want to have better online evaluators. Right now, I have offline evaluations. I want to use fine-tuned embedding models. And I want to improve my scoring rubric and probably build a data pipeline to periodically refresh the training data. And the tools part is something that I'm really interested in. I want to find a way to build connectors to tools like Jira, weights and biases, and MLflow so that I can grab the data from there and use it to generate documentation that can be presented to the FDA for software as medical devices. I also want to build the regulatory database to encompass more jurisdictions like EU and Japan. So that was my presentation. I hope you all enjoyed it.